So let's take a look at this image. You see that there are three lines. We have line AH, line BC, and line EG. Okay, there are some relationships that exist between these lines. This square corner here tells us that these two lines are perpendicular to one another. That means they form right angles. So every angle formed by these two intersecting lines is a right angle. And if you were to put these two right angles together, that would give you 180 degrees. That would mean that they are supplementary angles. They are congruent because they are the same measurement. Interesting enough, not only are these two angles congruent and supplementary, you could also say that these two angles are congruent and supplementary. And then in addition, these two angles are congruent and supplementary. Okay. On this other line that's intersecting with our main line here of AH, we have a 45-degree angle. It is vertical to the angle opposite it, the other acute angle. This would also be a 45-degree angle because vertical angles are congruent. If that's true, then we have this obtuse angle here. I'm going to give it two lines or two little curves there because they're different than the acute angle. This angle is an obtuse angle, and we know that it is supplementary to this 45-degree angle. That means that 45 plus this angle is going to add up to 180 degrees because they are supplementary to each other. So that means that this angle has to be 135 degrees. And if this angle is 135, it also means that this angle is 135 degrees because they are vertical. So we figured out that the original angle of 45 degrees was a clue that we could then find its vertical angle of 45 degrees, and we could then use that to find the supplementary angle of 135 degrees, and then use that to find the other 135 degrees. Now, if you add up 135, 45, 135, and 45, you get a total of 360 degrees because the measurement in a circle is 360 degrees all the way around, which is why on the perpendicular lines, the measurements also added up to 360 degrees.